Hey, g'day and welcome back to my shop. You may recall this tool that I made in a previous video. This is a pin wrench, and I posted the video that I did on a forum, and one of the forum members got back to me and said, why didn't you engrave your name and the date that you built the tool on it? And I thought, oh well, challenge accepted. If you watch any of Stefan Gotchwinter's videos, he always makes a big deal about putting his name and details engraved into his parts that he makes, and I got to hand it to him. He's an amazing machinist. I mean, the man built his own chuck jaws, for God's sake, and they were perfect, and compared to him I'm just a rank amateur. But I do have this tool, which is a diamond drag engraving tool, and I purchased this a while ago, and in conjunction with a CNC router or a CNC milling machine you can do some really fine engraving, and I'm going to show you how it works on this tool. So it's just a matter of setting the tool up. The forces acting on the parts are fairly low, so you don't need to really clamp it down super tight. I've just got this sitting on a parallel, and you don't even need to have this terribly accurately positioned level to the table, because the tip of the tool is spring loaded. So when you set your Z height and you set the tool depth height in your CNC software, the tip will be pushed down until it makes contact with the metal, and then it will drive down whatever depth you want. I think it has a depth of travel of about 8 millimeters, and depending on the hardness of the metal that you're engraving, you might only want to go 1 millimeter deep, or you might want to go 3 millimeter deep for harder materials. And the spring pressure will keep the diamond tip in contact with the surface. So even if I don't have this positioned perfectly parallel, it won't matter. So I'll set this up. I'll just show you my software so you can see how I've set the tool path. Well, sorry about filming my own monitor, but it's the best you're going to get. The software I'm using here is Kanban, and I've just simply created the text string and then positioned that at 0, 0 on the screen. And with the engraving tool set, which looks like this, so if we go to machining and engrave, you can set here, actually set a separate one now, but you can select the tool path. You can then set the depth that you want the depth increment to be and the target depth. So on this one, which I set up previously, I've set my depth increment to 3, my target depth to -3, and my feed rate at 300 millimeters per minute. And you can see the actual tool path here in blue, and you can see the travel lines with the Z travel in red. So I usually try this out on a bit of scrap material first, just to be sure I've got my text height correct, and I've already done that. So we'll go ahead and create the G code. I'm just going to delete this one. Okay, so I've got my original engraving tool path there. So machining, produce G code. I've already created one of these. So pin wrench, yes, right, so that's there. So in Mach 3, I'll just enable my machine, open my G code, and I'm going to set my tool 0, and we'll go from there. Okay, so you should be able to see here I've got my engraving tip driven down. It's just touching the surface of the stock. I've set my Z to 0 at that point, and what I want to do now is to lift the engraving tip up 2 millimeters and 0 again. When I execute the G code, the tip will be driven down 2 millimeters, hit the surface, and then keep going another millimeter, because I've set my depth of cut to 3. So at this point I just want to lift that tool tip up. So I'll just do a manual data entry, so G0, Z2. Right, I'm going to set my Z again to 0. I've got my G code already set up, and just because I second guess myself a lot, I'm going to start this with a single block. as I step through the G-code. So here we go. So cycle start. It should lift 3. Right, it's going to go to its first X and Y position, and it should go now to Z1, and the next one should be Z minus 3. So the engraving tip is basically a millimetre below the surface, if you can imagine it that way. So here we go, we'll just run the code now. Okay, so I'll give you a close-up look at that. There you go. That's diamond drag engraving. For my money, it's a lot safer and predictable, more predictable than say rotary engraving, and I don't really have a spindle capable of producing the speeds that you would need for rotary engraving anyway. And there's very minimal burr that's raised in this process. You can feel it, and if you're really worried about it, you can sort of rub that over with a very fine oil stone. So there you go. Thanks for watching.